Hello, my name is Asia Shavers, and today I'll be diving into the SSH protocol and its widely used implementation, OpenSSH. In my slides, I'll be explaining what SSH is, how it works, cons associated with SSH, how I will implement it into my Linux environment, and how OpenSSH makes the SSH protocol functional. I will also be going over several hardening tips that I'll be using to configure and strengthen SSH in my lab environment. Starting with my first slide, I will go into what SSH is and what it stands for. SSH stands for Secure Shell. It is a cryptographic network protocol that is used to securely send information to a computer over unsecured networks. Secure Shell establishes an encrypted data communication between two computers, which prevents possible attackers from reading or modifying data that is in transit. To protect credentials and session activity, strong password authentication is used. Secure Shell is commonly used to manage systems, transfer files, configure network infrastructure, and interact with applications remotely. Secure Shell also supports secure file transfer tools like SCP and SFTP. SCP is known as Secure Copy Protocol, and SFTP stands for Secure File Transfer Protocol. These tools allow for administrators to move backups, scripts, and application data. Secure Shell is used in data centers, cloud environments, and enterprise networks. Secure Shell is widely used by administrators to remotely manage their servers, maintain those servers, and troubleshoot potential issues. Secure Shell is so integral because of its secure remote access. And now on to how Secure Shell works. Secure Shell uses the client-server model. The client-server model is when a client initiates a request for a service or program, and then the server responds by providing the request. Secure Shell relies upon public key cryptography for securing authentication. Public key cryptography uses two separate keys, a public key and a private key. The private key is only shared to the owner, while the public key is shared openly. Data is encrypted with the public key and then is decrypted by the private key. This means without both keys, the data can't be accessed. This ensures that only trusted users can access sensitive information and establish a secure connection. Secure Shell runs over TCP using the default port 22. Secure Shell uses tunneling, also known as port forwarding, as a secure method for the transmission of data. It creates encrypted pathways to transmit data. This allows users to secure traffic and bypass network restrictions by creating secret tunnels for local, remote, and dynamic port forwarding. And now onto some of the cons associated with Secure Shell. The first con is that Secure Shell requires further configuration to remain secure. For example, passwords can be vulnerable to brute force attacks. This means that configuration is important to fit that user or administration's need. The second con is having to manage keys-based authentication. Public key encryption is more secure than passwords, but it requires additional management. All keys need to be generated, stored, and distributed properly. This means taking away access from leaked or forgotten keys to maintain the integrity of Secure Shell. The last con is the default port of 22. Port 22 makes Secure Shell reachable from the internet, which is a very large area that attackers can take advantage of. Firewall policies, IP listings, and monitoring are all important solutions to mitigate exposure. And now onto how I will install Secure Shell on my Linux environment. Secure Shell is not pre-installed into the Ubuntu system. First, I will make sure my system is updated by using the command sudo apt update, and then I will install Secure Shell onto my server by using the command sudo apt install OpenSSH-server. And to make sure that Secure Shell is installed, I would do so by checking its status by using the command sudo systemctl1 status ssh. And SSH provides a secure channel for Linux to interact with Git and manage virtualization platforms like VMware. And for my next slide, when I was researching Secure Shell, I came across Open Secure Shell. So in this slide, I will go over what it is and how it relates to Secure Shell. Open Secure Shell is an open source implementation of the Secure Shell protocol. It provides the software programs that allow Secure Shell to be used. Open Secure Shell includes tools that can be used on servers and networking devices. Tools with commands such as SSH, SSHD, SSH keygen, and SSH agent. Secure Shell is only a standard, and Open Secure Shell is the implementation of the Secure Shell protocol. And this is what I will be installing in my Linux system. And now onto my hardening tips for Secure Shell. I have 4 hardening tips, and the first one is network restrictions. Restricting network access severely reduces the possibility of attacks. This includes configuring firewalls rules to only allow trusted IPs. It also means permitting Secure Shell traffic from internal LANs or VPN addresses. By reducing the number of systems that can attempt Secure Shell access, it decreases the likelihood of external attacks. My second hardening tip is to change the default port. As mentioned before, the default port for Secure Shell is 22. So relocating Secure Shell to a different port will reduce feedback noise that may clutter log scanning and limit the opportunity for attackers. A potential port could be 2222. My third hardening tip is to disable root login. Disabling root login will prevent attackers from accessing the most powerful accounts. By doing this, it will force administrators to authenticate their individual accounts. My last hardening tip is to monitor your Secure Shell server. Because Secure Shell is such a strong tool and can be accessed by many, all activity needs to be logged and monitored. Tracking login attempts, failed authentications, and anything unusual should all be addressed. And now on to my conclusion. In conclusion, Secure Shell is a widely adapted protocol that provides secure and encrypted remote access for system administrations and management. It protects data through strong encryption and authentication, which makes it essential in enterprises and cloud environments. I cover what model SSH operates in and its use of key-based authentication. I went over the cons that were associated with Secure Shell and how Secure Shell is secure, but it does require detailed configuration and ongoing maintenance. I went over how I plan to install Secure Shell into my Linux environment, and then I covered that Secure Shell provides the framework for communication, while Open Secure Shell is the implementation of the framework. I then followed by the hardening practices I will implement, and overall, what I gathered from my research is that Secure Shell, with the combination of Open Secure Shell, is a reliable, secure, and effective protocol to manage and maintain a system remotely. It provides a reliable foundation for critical Linux-based systems. And in my last slide, I've included my references.